Where air handling ducts pass through the fire-resisting escape routes and compartment walls or floors, the fire resistance must be maintained. General-purpose ventilation ductwork systems are constructed to the Building and Engineering Services Association, Guide DW 144. This ductwork, however, offers little or no protection against fire spread. Therefore, the integrity is generally maintained by using one of three methods: fire dampers, fire-resistant ductwork, or fire-resistant enclosures. Let's have a look at these in more detail. A fire damper is a device installed at the point where a duct penetrates a fire escape or compartment wall or floor. Under normal conditions, the fire damper allows ventilated air to pass through a duct, wall or partition. In a fire situation, however, it closes automatically to prevent the passage of fire or smoke. Fire dampers may use fusible links that, when heated, release a spring-activated mechanism which closes the damper. Alternatively, the fire damper may contain a matrix of material coated with intumescent compound, which, when heated, swells up and closes the opening. In high-risk areas, for example, hotel or hospital escape routes, which may contain a number of separate compartments and people sleeping, fire dampers may need to be triggered by fire detection equipment. Thermally triggered fire dampers are not acceptable for these applications. Fire dampers should have access to allow for inspection, testing and maintenance of both the damper and the operating mechanism. The operation and condition of all dampers must be checked regularly, and tests must be recorded. When checking dampers, the penetration seals surrounding them must also be carefully inspected. Fire dampers are not generally suitable for kitchen extraction ductwork because a build-up of grease can prevent correct operation. If tested and certificated fire-resisting ducts are installed, then fire dampers may not be required. A representative sample of the fire-resisting ductwork should be inspected if installation records are not available. This should be done where the duct passes through compartment walls and escape routes and at other access points. Ductwork must always be sealed and supported on either side of compartment walls or floors to ensure that penetration seals are not damaged by ductwork sagging if a fire occurs. Fire-resistant enclosures may be used for air handling ductwork between compartments and escape routes. Fire-resisting enclosures may be of traditional construction, for example plasterboard, or they may be proprietary service ducts or shafts. These use fire-resisting board materials, for example calcium silicate or cement-based boards. Sample inspections of the protected shaft should be undertaken at access points and where they pass through compartment walls and escape routes. If an assessor is not confident that an enclosure provides adequate separation, it should again be recorded in the risk assessment, and a more thorough, invasive third-party inspection should be considered. All fire-resisting ductwork, dampers and enclosures must be checked on a regular basis, and records of all checks must be maintained.